Alright guys, I'm going to go over some problems from the practice for derivative exam number 1. So the first one I'm going to look at is number 3. This one gives you the function. It's a quadratic and asks you to find the equation of the secant line in this given interval. So the first thing we need to find is the average rate of change over this interval of the function. And remember, that's when you connect the endpoints, giving you the secant line, and we want to find the slope of that first. The formula for the slope of the secant line looks like this. It is f of b, which is 5, minus f of a, negative 1, all over 5 minus negative 1. So the formula is going to look like that, f of b minus f of a over b minus a. And now I can evaluate each of these. So f of 5, I'm going to write this over here. When I plug 5 in, I get 49. And remember, that's just the coordinate, 549. That'll be helpful in a minute. So 49 minus f of negative 1, plug in negative 1, you get 2 minus 1, which is 1. So f of negative 1 equals 1. So that is another coordinate. All over 5 plus 1, which is 6. 48 over 6 is 8. That is the average rate of change of the function in this interval. So now we have our slope. We have 2 points to choose from. I can use either one I want. I like the smaller numbers. I will use the smaller one. Point slope, I can use point slope formula. Y minus the y coordinate equals 8 times x minus the x coordinate, and you have the equation of your secant line. Okay, so that's number 3. 1, 2, 3, and 4 all look very similar to that, where you've got to find something about the average rate of change, and then sometimes you have to find the secant line formula or equation. All right, so that was that one. Let's do number 6. Number 6 is asking for the derivative at a point using the definition of the derivative at a